We will begin graphing quadratics with standard form. Y equals ax squared plus bx plus c is our standard form. A quadratic is a function that can be written in this form. A cannot equal 0, but B and C can. In other words, you have to have an x squared term for it to be a quadratic. We also call a quadratic, when it is graphed, a parabola, if you forget that. The maximum or minimum point of the quadratic or parabola is called the vertex. That is the first thing we are going to talk about. So just very basic here. On this, the vertex is the very lowest point of the U, which is what point there? 1, negative 2. Would we call that a maximum or a minimum? A minimum, because it's at the bottom. Vertex here is the very top point at negative 2 up 3. We would call that a maximum. I don't really feel like we need to do the other two like that. We know what a vertex is. All right, so key features at the bottom, things we need to be able to find on a quadratic at the very bottom here. A couple things. When your a value is greater than 0, what does greater than 0 mean in math world? Positive. If your a is a positive number, the parabola opens up. When a is less than 0 or a negative number, the parabola opens down. In other words, in those two examples we just did, the first one would have a positive a value because it opens up. The second one would have a negative a value because it would open down. Okay? A can also tell us the width of the parabola. If a is a number less than 1, somewhere between 1 and negative 1, that's what this means. The absolute value is less than 1. It basically means a is between 1 and negative 1. Then the parabola is wider than the normal function y equals x squared. If a is exactly equal to 1, then it is the same width as the parent function y equals x squared. And if a is a number either bigger than 1 or smaller than negative 2, in other words, a bigger negative number, like 2, 3, 4, all of that, negative 2, 3, 4, then it is narrower, which I don't know why this blank is so small, but narrower. Okay, so we'll use that to tell the width. The highest or lowest point on the parabola is called the vertex. Here's a formula that we're going to need to know. To find the vertex, you are going to do negative b over 2a to find the x value. Plug it in, solve for y. That's going to give you your y value. That negative b over 2a formula also gives you what we call the axis of symmetry. If you remember that, that's that dotted line that runs right down the middle of the parabola. Half is on either side. And then your x-intercepts, you can get 0 x-intercepts, 1 or 2, where the parabola crosses the x-axis. The y-intercept is where the parabola crosses the y-axis. This is your c value, always.
For school, we need.
So on the back of that, if I give you a standard form function, just from what we talked about here, we have 3x squared minus 7x plus 1. What part of that tells me which way it opens? The 3. Since it is a positive 3, it opens which way? Up. Now, this is the vertex of max or min is a result of whether it either opens up or down. So think about it. If it opens up, it looks something like this. Will the vertex be a max or a min? Min. And because that number 3 is a number larger than 1, is it wider or narrower than the parent function? Narrower. It's the exact opposite of what you want to think. If it's a bigger number, it actually makes it thinner. What happens is the bigger numbers stretch it up faster, so it pulls the sides in and makes it skinnier. Fractions, like fractions less than 1, like 1/2, 3/4, any of those, that's what's going to make it wider. Okay? All right, so same type of thing for the next one. What is going to tell me the direction of opening in 6? The negative 5/4 there tells me it opens which way? Down, which makes our vertex a what? Maximum. Now careful on this one. Wider or narrower just depends on whether that number A, doesn't matter whether it's positive or negative, it just matters whether that number is bigger than 1 or smaller than 1, ignoring the positive negative. So is 5/4 bigger than 1 or less than 1? Bigger, which makes it what? Narrower. A lot of people see fractions and immediately want to go to wider. So just be careful on that. Take a minute on your paper and fill in those same blanks for 7 and 8, and then we'll get started graphing. All right, so on these real quick, oops, why did I erase that? Should have that 7 opens up, which makes the vertex a min, and that fraction that is less than 1 makes this a wider graph. Okay. And last but not least, this should open down, which makes your vertex a max. And that decimal of negative 0.6, the negative doesn't matter, but the 0.6 being less than 1 makes it also wider. Okay? Now, let's quickly just talk about what a basic parabola looks like. This is what we call the parent function, y equals x squared. We call it the parent function because it's the most basic quadratic that you can have. It has the most basic vertex, which is what? 0, 0. Okay, it has an a value of 1. Everything is simple. This is the most simple quadratic that you can have. So we're going to compare every other parabola to this one. There are multiple ways to graph these. Some people will teach you to make a table of points to find these. I find that that's a lot of just plugging in numbers. I can definitely show you that way, but I tend to use patterns to graph these. And what I mean by that is this. If you look at the basic quadratic, and this quadratic, it's a little bit funny because it counts by halves here. Here are my 5 points that I have on a quadratic to start with. What are these 5 points? The vertex starts at where? 0, 0. Either side of that, I would count, and it's kind of like you're counting a slope, but this isn't a slope because it's a quadratic, not a line. So you'll see what I'm saying in a second. It kind of goes over 1, up 1 that way, and goes over 1, up 1 the opposite way from the vertex. Then if I was counting from the vertex again, it goes over how many to get to the next point? Over 2, up 4, over 2 the other way, up how many? 4. If I continued that pattern, you're only required to do 5 points. But it went over 1, up 1 either side, over 2, up 4. If we went over 3, it would go up how many? Think about it. This is an x squared function. Over 3, up 9. There you go. You can continue that pattern with any quadratic because it's x squared. Whatever the x goes over, it's going to go the same the squared distance up is what I'm saying for that. So that's why it's over 1, up 1 because you're squaring the 1 to get 1. Over 2, up 4 because you're squaring the 2. You could go over 3, up 9. Over 4, up what? 16, and so on. We're going to use that pattern to graph because that's going to change based off of your a value. But I'll show you what I mean by that when we do that. Okay? So the first thing we're going to do for any of our quadratics in standard form is that we are going to find the vertex first, which means you're going to use that lovely little formula, negative b over 2a. Okay? This right here, this sentence over here, this is what people say to write a chart out for these, which you may certainly do. I will show you both ways. I'll always use the pattern to graph because it's easier to me. You may certainly choose to do a table. Okay? I just don't like plugging in a million numbers. It's annoying, but that's up to you. So if we practice graphing, at the very bottom here, number 9, I have my a, b, c value, right, given in the formula. So I start by just knowing what a, b, and c are. I don't require you to write these out normally. It's just the first one. We're going to go through what are these. To find your vertex, you're going to use negative b over 2a. On a standard form, that's always what you do first. So if I plug in my values for that, what's it going to look like? Perfect, which gives me negative 2 over negative 2, which tells me the x value of my vertex is what? 1. To find the y value, the easiest thing to do is what? plug it in. So I take my quadratic. I'm very careful about the fact that this starts with a negative, then I square the 1 plus 2 times 1 plus 3. Remember, if there are no parentheses, you may not put that negative inside the squared with that 1. So when I work that out by hand, that's going to give me negative 1 plus 2 plus 3, which is a vertex of what now? 4. So my vertex is 1, 4. What else did this negative b over 2a give me besides the x point of the vertex? Axis of symmetry right here. That's x equals 1. It always goes through the vertex. So that is how I start graphing. We know how to graph the point 1, 4, hopefully. So over 1, up 4, here's my vertex. Axis of symmetry, we typically draw as a dotted line running through the middle of your graph, right there. So there's my dotted line. It's always a vertical line. It always splits your parabola half and half. Any issues with this so far? No? All right, so here's how the pattern works to then graph the rest of your points. We said from the vertex, we went over 1, up 1, over 2, either way, up 4. If you wanted to continue, we went over 3, up 9, and so on. Your A value, whatever that is going to change this pattern. First, my A value tells me that this opens which way? Down. So the first thing that A value does is changes it, instead of up 1, it changes it to down. It only changes the up part. It does not ever change the over 1, over 2 part. So the negative changes it to down 1. If the A value was a different number than 1, you would then multiply those numbers by that A value. So in this case, because that A is 1, if I multiply that by either of these numbers, is that actually going to change anything? No, not at all, right? But if that A value is 2, I would multiply it. So what this tells me is from my vertex to get my other points, I'm going to count over 1 each way and down 1. So first, I go over 1, down 1, draw a point, over 1 the other way, down 1, draw a point. Second, from the vertex, this is always counting from the vertex, over 2, down 4. So that's going to be over 2, down 4 is right here, over 2, down 4. You then have your 5 points to graph, and that's all you need to do. So you're not plugging in any numbers at all. You're just using that pattern and changing it based off your A value to graph your quadratic. If you are a table person, you may draw a table, put your vertex in the middle of it, and then you pick 2 points on either side of your vertex to plug in. So directly below 1 is 0 and negative 1. Directly above 1 is 2 and 3, and you would plug in all 4 of those x values to find your y values, or match them based off the patterns. But to me, if you learn this pattern, it's less work. It's just up to you how you want to handle that. Okay? Any questions on how we got those? We're going to practice with that, so don't worry. The good thing with the pattern is you can use it with all 3 forms. So I prefer to use it, but like I said, it's up to you. All right, flip over to the next page. We'll practice again. We start all of these by finding the what? Vertex. What formula do we use to find the vertex? Negative b over 2a. So I start off with x equals negative 4 over 2 times 2. This gives me an x value of what? Negative 1. That is 2 things. What's one of them? It's the axis of symmetry.
Upper school, we need sophomore boys, A through L.
All right, so it's the axis of symmetry. It is also what? X value of the vertex. How do we find the y value? Plug it in. So I go back to the original equation and carefully plug in my x value, making sure to use parentheses and follow order of operations, which says to do what first? Exponents first, so I square the -1, making +1. That gives me 2 times 1 is 2, minus 4, plus 1. So what's my y value? -1. Because my a value is +2, that tells me is my vertex, or does this open up or down? Up, and my vertex will be a min. So I start by graphing my vertex and my axis of symmetry. -1, -1 is my vertex. Axis of symmetry is right here. Okay. Now, let's practice the pattern again for graphing. We said on the parent function, our pattern is always over 1, up 1, over 2, up 4. Never changes to start with. Then we change it using our a value. So since my a value is +2, positive, does that change the up? No, it stays up because it opens up. If it was negative, it would go down. The 2 we take and we multiply by whatever we were going up. So that changes this 1 to a 2 and this 4 to a what? 8. So that means from my vertex to get my other points, I'm going to go over 1, up 2, draw a point. Over 1 the other way, up 2, draw a point. Notice, axis of symmetry, your points are symmetric on either side, always. They match. Then again, from my vertex, I'm going to go over 2, up how many? 2, 4, 6, 8. Over 2, up 8. And that will be my full quadratic there. Notice, my a value is greater than 1. Is this quadratic wider, narrower, or the same width as our original parent function? It is narrower, if that's even a word. I'm using it today because that 2 value stretches it up higher. Do we have any questions right now on that pattern? I know that's kind of a weird thing. Yes?
So you don't multiply the over values at all?
Nope, the over things are never going to change, ever. It's always the up part that changes. The up can change to down, and you multiply the numbers there, because it's just the y values that are changing.
So how do you change the numbers again?
You multiply by the a value, whatever that is.
Okay.
Okay? Any other questions on that pattern thing? We'll practice it again, because we'll see it in 11, and then vertex form, and then intercept form. So lots of practice with that same process. All right. In that case, let's try 11. 11 is not written in standard form. 11 is shown in different forms, so if you need to rewrite it so that your x squared comes first and so on, totally fine. You can start by putting your x squared term first, then your x, then your 2. And the first thing we always find on all of these is the vertex, so we would do x equals, what's negative b going to be? +1 over 2 times a, which is -1/2. So this gives me 1 over -1, or an x value of -1, which is 2 different things for us. It is our x point of our vertex. It is also what? Axis of symmetry. Our a value tells us that this opens which way? Down, which means my vertex will be a max. And to find the y point of my vertex, what do? Plug it back in. That's going to give me -1/2 times -1 squared minus -1 plus 2. Carefully working this out gives me -1/2 plus 1 plus 2. You may use decimals for these, especially when it comes to graphing. I find it easier to graph decimals than I do fractions. So -1/2 plus 1 plus 2 is going to give me what? 2.5. Any issues with that? All right, so we start by graphing our vertex and our axis of symmetry. -1 up 2.5, we just kind of estimate where that is. And then we graph our axis of symmetry as our dotted line right down the middle there. Now, let's practice that pattern one more time on this type. So that pattern, we said we always start with over 1, up 1, over 2, up 4. So 2 things to do with this one. We use our A value. First, the negative on the A value changes the up to what? Down. So both of these change to down. Never changes that over part at all. Secondly, the A value is a half, which means I take that and I multiply that. That's going to change this 1 to what? 1 times a half is what? A half. 4 times a half gives me what? 2. So, from our vertex to get to our other points, I'm going to go over 1 either side and down a half, which is kind of nice because I started at 2.5. So if I go over 1 down a half, that lands at directly at 2 on either side. Over 2 down 2 from that would be landing right at 0.5. Again, when you have to do those and it's at a weird point like that, 2.5, you're just drawing an estimate of that. You can do down 2 from 2.5 is a half. And you're connecting, which you can then see that A value made your graph wider, narrower, or the same? Wider. Fractions make them wider. All right. Do we have questions with that pattern thing right now before we try it again with vertex form? I passed the bags out so that we can practice graphing on our whiteboards once we're done. So that'll be some extra graph practice with that. Okay? I'm going to run real quick through vertex form and standard form, or vertex form and intercept form on the next page, if you don't mind flipping. All right, vertex form, you've probably seen before. Looks like this. Okay. It's translated right or left, H units, and up or down, K units, which basically means the vertex is H and K. You just pull it directly out of the formula. The axis of symmetry always runs directly through the vertex, so it will be the same as whatever that H value is. And just like before, the graph opens up if A is greater than 0 and down if it is less than 0. So the only thing that changes in this process is how you find the vertex, which is actually easier in this case. You don't have to do any work to find it. You just pull it directly out of the equation. So notice in this equation, it's x minus h. Since there's a minus in the formula, it means whatever you pull out for that x value of the vertex, it's always going to be the opposite sign of what it looks like. So that means when I go to 13 here and I say, look at this for h and this for k, h is not actually positive 1 because there was a negative in the formula. What is h actually? Negative 1. I change the sign of the h. I do not change the sign of the k. So the k is negative 2 for your vertex. That tells me what about my axis of symmetry? Where does it go through? Negative 1. So notice, all you had to do to get the vertex is pull it out of the formula. Vertex form is the easiest form to graph. So I start by graphing
For boys, M through Z, please.
negative 1, negative 2. And I start by graphing my axis of symmetry. Just like we graphed the other ones, we start with those two things. And we're still going to use that pattern to graph our other points. Our pattern always starts as over 1, up 1, over 2, up 4. Someone tell me what is my A value in this formula? 1, because there is nothing in front of this parentheses, so you may only assume it's 1. If it's positive 1, does any part of that pattern change? Not at all. So from my vertex, over 1, up 1, draw a dot, over 1, up 1 the other way, draw a dot, over 2, up 4, draw a dot, over 2 up 4, draw a dot. Always counting from your vertex. Questions about vertex form so far? No? All right. Last vertex form, and then we'll just talk intercept form real quick. If I'm given 14, first, what is my vertex in 14? 1, 5. Good. Pull that directly out of the equation. That means, what about my axis of symmetry? It is 1. So we start by graphing that. 1, 5, axis of symmetry directly down through that. And then we use our pattern to complete our graph. It starts over 1, up 1, over 2, up 4. Now we use our A value to change that. Our A value is negative 1/3 here, so that changes two things. First, what does it change? Makes it go down instead of up because of the negative. What else do I do with that 1/3? Multiply it. That makes this number 1/3. This number 4/3, which is like 1 1/3, if you want to think about it as mixed numbers to graph. So from that vertex, this is really going to be an estimate because, I mean, these are tiny little graphs here. I'm not really judging you on whether it looks like a third or a half. It just has to be somewhere between one value different. So over 1 down 1/3 would be not very far down from that 5. Over 2 from your vertex down 1 1/3, I would just go 1 and a little bit past that on either side. You're just making estimates here and connecting your points. Questions on that? The last form is kind of the least useful, not quite as often seen, but we're going to talk about it. It's on the next page. We'll just do one example with this, and then we'll do some practice. Okay. This is intercept form. It's called intercept form because it gives you the x-intercepts. The x-intercepts are pulled right out of this equation here. They are P and Q. Notice again, those have minus signs with them. So because there's a minus sign with them, whatever it says inside the parentheses, you're going to use the opposite sign. The axis of symmetry is halfway between these two. So to find it, you can add P and Q and divide by 2. It's like an average. Again, the graph opens up if your A value is positive and down if your A value is negative. So the only difference here is how you find the vertex. This is why I call it the least useful form. Vertex is a pain to find with this one. You have to find your x-intercepts first and then find the middle between them and then use that to find your vertex. So here, what would be my x-intercepts in 16? 1 and 5. Directly out of the equation, opposite of what you see. It looks like -1 and -5. You use the opposites because the negatives were in the formula. To find your axis of symmetry and your vertex, you add those two together and divide by 2. It's always directly in the middle. A lot of times if you're graphing and you graph your x-intercepts at 1 and 5, most of you can kind of eyeball where's the middle of that.
Junior girls, A through L.
All right, you're a junior girl. Have fun. All right, so that means my vertex, the x value is what? What's halfway between those? 3. That's also going to be my axis of symmetry. What's the best way to find the y value of the vertex? Plug it back in. If you don't know, that's always the best way. So -2 times 3 minus 1 times 3 minus 5. Order of operations says to do what first? Parentheses. That gives me 2 and -2. And I do -2 times 2 times -2, which gives me what as my vertex? Positive 8. All right, so then we continue graphing by graphing our vertex at 3, 8. and our axis of symmetry right down through that. And then we'll finish up using that same pattern, which is again why I like to use it, because it's the same thing every time. Starts over 1 up 1, over 2 up 4. Then we use our A value to change it. What's our A value this time? -2. Since our A value is -2, that changes two things. Changes up 2, down, and what does it do to these numbers here? Multiplies by 2. So from this vertex up at the very top, I go over 1, down 2, over 1, down 2. If I go over 2, down 8, I land right where? On my x-intercepts that I already had graphed there. So it should match up with those. Those were already there, and you may connect your dots. All you need is 5 points for a quadratic. Okay? All right.